Well, here we have a USB speaker, Boomshaker. That's the model of it apparently. Not a lot of info on it that I can find anywhere, but it doesn't turn on. If we try pushing any of these buttons, that one's marked pairing mode, that one's marked a USB or base boost, and that one's marked as auxiliary in or lighting, but no combination or holding any of them or whatever. I can't find any info on what's the on off button, but none of those seem to be working at all, so we can safely say that I think it's not turning on for sure. So behind the bottom cover I'm picking is where the batteries are going to be, mainly because up the top there is what looks like the guts of it all. So yeah, there's a cover there, so I'm going to say that's batteries. So if we feels a bit stuck on there, get all the screws out. Yep, bit of foam padding around the sides to keep all of the air from escaping. It just gives the speakers a nice solid response. And here we go, a couple of 12 volt sealed batteries. Oh, I get the arm in the way. 12.3 volts, and if we go at the top, 12.3 volts. So both appear to be fairly well charged. So that is not our problem either. I mean, it doesn't turn on with the mains cord connected. So I mean, yeah, it's a good thing to check though. So there's the unit. We have the power supply on top, and looks like the rest of it on the lower board there. I know this board's okay because off camera I plugged it in while it was plugged in and checked the battery voltage, and they came right up to 13 over 13 volts, so it is supplying enough power to charge the batteries. So we know that the top board is okay, and that is not the cause of the problem, and also because it doesn't turn on with it unplugged anyway, so with the batteries as charged as they are. So just a few screws around here, one in between the sockets, the nut around the socket there, and the knobs just pop off, and there we go. Not overly complicated, but certainly everything on one side, which is good. We'll have the main amplifier under the heatsink, of course. We've got our row of battery level status LEDs, and yeah, here's our power in and our battery in. And there's a fuse, so this is going to be our input side of things. Alright, so here we have the input circuit. We've got our positive and negative coming in here. You can see the green trace, the positive comes through to the fuse, it goes through the fuse, and then you can kind of see it heads back under the fuse. You got those through holes there which are on the trace I'm talking about, so it's positive through to here. And then if we have a look under here, I'll just push those out the way. Oh, what about that? Oh, yep, so it comes into this diode here. That diode is actually okay, so that's the cathode there, so it's not flowing through the diode this way. That will be for charging, I'm guessing. It'll come into the diode and out through the fuse to the batteries. And then it also comes down this side of the diode to here, and nowhere else on the top side. So it's just, we've got to follow it through these through holes up here now. So that diode goes to that resistor, which is seriesed with this resistor, which then goes into this. Oh, here we go. Yep. So yeah, comes through. Make sure you can see that. Goes through the diode into here, through the resistor, through this resistor, and ends up at this MOSFET. And we know it's a MOSFET because one entire set of 4 pins is connected together. 3 on the other side are connected together. So that's our gate and source. Oh, sorry, drain, drain and source. And our gate is the single pin on its own. So we know that's going to be a MOSFET, which is going to be used for the charging side of things. When it's charging, that'll switch on and feed through the resistors, through the diode, and back into everything else, including powering this device up. Alright, let's flip it over and see where that fuse comes through. It appears to come through here, which is only a jumper. It comes through and down to here. So back on the other side. Okay, it's coming down to here. And then it goes into this MOSFET. Right, so we need to find out if we have a voltage on each side of that MOSFET, whether it's being told to turn on or not. 51 k ohm resistor off the gate to the actual power, feed in, and a 6802. That's going to be 6.8 k, isn't it? I'll double check that. 68 k, 68000, 68 k. So yeah, 51k and 68k, which means that's a voltage divider really. I would have thought that the 68k would be the lower one. Okay, so on our fuse we have 12 volts. Down on the MOSFET, of course, we're going to have 12 volts coming in after the fuse. Here we go. And what do we have on the other side? Nothing. Why do we have nothing? Make sure our scope's still running. Yep. What is on the gate? On the gate we have 12 volts. So that, depending on the MOSFET, will probably mean it should be on or it should be off. Let us look up a data sheet. 4425 data sheet. This is a P-channel MOSFET, so it ain't going to turn on until the gate is pulled low, which is why I was wondering why the lower value resistor was on the feed in, because you would think as a voltage divider, if you tried to pull this low, that being higher would trump it and would still allow the gate to be, at a higher voltage. Somewhere the power must be flowing such that there's some intelligence that can activate that MOSFET. So there must be a standby circuit running off all this somewhere. Well, if one was to pop the fuse, one might notice that there is another path. There is a resistor off the output of the fuse. Goes to this through, what do we got there? 224, so 220 k ohm and a 30C, which is whatever the hell that is. I haven't seen a lot of resistors with numbers on, with letters on them, but 14 k ohms in circuit. You can see a fine trace running out of the middle of those two resistors. One running down all the way down here. Okay, there's a through hole here, but it stops at this capacitor, and then through to the other side, and that one goes up to top holes. So let me just have a quick look at the holes. Where does the top one go? That goes to ground, does it? Okay, it appears it goes to ground. So that's a little resistor divider network to turn 12 volts into some other low powered voltage for what goes on here before it's turned on. So we'll see if there's anything. I'll put the fuse back in. What? 1 volt. That's not even a volt. That's like 700 millivolts. Well, that's really not going to do anything, is it? If that's supposed to be our standby power on. Let me just squeeze this around and see if I can have a measure under the fuse there. So we'll go to that side of the resistor. We've got 12. It's going to go off scale. Yep. We go in the middle of the scope. Resistor, we've got, there's here, nothing. I know I've been missing something all along. I made an assumption in the beginning that this is a 12 volt system, and it has 12 volt batteries, and I thought I just thought that they were paralleled up for longevity. But more fool me, this is actually a 24 volt system, and I've been feeding it 12 and wondering why nothing's happening. So let's try this again. And yes, those pins are joined on that end. It doesn't matter, they're joined anyway. Where are we? Where are we going? Battery terminal. There we go. Let's reconnect our feed in. There we go. And try and figure out this time why it's not working. Microscope light is not 24 volts, so I'm shared power supply at the moment, so it's going to have to be a little darker. So we have our 24 volts coming in, and our voltage divider came down to here, remember? So what do we got down here? We still have not a lot. That's interesting. Alright. So, that's still going. Oh, I can change scale while I'm looking at it. Let's go 10 volts per division. For some reason I thought that was going to freeze the capture. So we got 24 volts in. Which is down on this MOSFET. Comes into the fuse to here. This needs to be turned on in order to feed the rest of the system. I don't know what is supposed to turn that on. Still nothing else is going to be working because we have no voltage over here and nothing here and nothing here, nothing here, because that's our charger input side of things. So charger comes through to this FET and out to the battery. So this transistor here, this transistor is what turns on the MOSFET that lets the battery voltage through. This is the base of this transistor, which is controlled by the microprocessor. When I stuck well, when I had 12 volts coming in the connector, the charger connector up here, I was getting, it was running somewhat. I had 3 volts running down here. The CPU had 3 volts. The oscillator was running. So we're still trying to figure out where this secondary, where the standby or battery powered, where the battery powered feed activates itself. I wonder if it's a button combination. Let's go down all these here, just see if we've got anything on them that might trigger the processor to work. So there's a whole lot of half volt signals. And then nothing, oh, half, nothing. Ooh. Full rail up here. Full rail feed up here, which is probably for feeding the LEDs on the front, which is interesting. Okay, let's follow that. So we got 24 on here, which is coming from this inductor L10. If we follow that trace, comes down to here. Yep. Which probably goes across to here. Yep, okay. I'd say there's a jumper in that through hole from that side to that side. That definitely has 24 on it. And that goes out to our MOSFET. It turns it on. Okay, so if we trace that back, that goes to that pin there. So where does that go on the front panel? Maybe that goes to a if that goes to a button that pulls that signal low, that's going to turn that MOSFET on, in which case the processor will start up and turn the transistor on, maintaining the battery feed. I bet that's what happens. Maybe we've got a problem with the buttons on front, because I pushed all them and it didn't turn on. I feel like we should try this on the bench first, just to prove our point. I should be able to ground that pin and this thing should turn on, and we will see that in the secondary voltage rails that come up on the other side. So I'm going to stick a probe on this big one down here, and this should, down off the end of this inductor, should I go there? We'll go there. We'll see what happens. It'll either be oscillating or it'll be the main output. And then I'm going to come up here. Now we're going for, don't get your tweezers across the rail. Right, so we're going for that pin there, which is going into L10, and I'm going to just squeeze it across the pin directly above it, which is ground, and we should see this rail come up. Here it goes, and it came off again, so maybe I need to hold it down. Here we go, 2, 3, okay, 3 seconds, and the current went from 10 milliamps to 90 milliamps. Let's just see if this stays on. It looks like it is staying on. So what else have we got? That one's a 5-volt rail. If we come up to the inductor beside it, that is a 12 volt rail, and if we come over to the CPU area, what have we got going on down here? 3 volt rail. How about that? So it's working without a user manual. Who knows what button's supposed to do what, huh? You know, could be anything. So we have effectively reverse engineered this entire board for the sake of finding a broken on-off button. How about that, eh? Wasn't that fun? Looking down at the front board, which has the buttons on it, you probably can't see it. This is where I actually lost a bunch of footage, so I'm going to recap. Isn't nothing too critical, but what I found was that in the center button around the bottom left connection, it was actually broken, cracked right around it, and I could prove that with a measurement from my multimeter that when I push the button, that pin is connected to ground. So that is our on-off button right there. Then what I did when I put it all back together to try it, it still didn't turn on, and I found that for some reason that signal is getting pulled down, and it doesn't take much. It only has to be down to about 22 volts, 21 volts from about 24, so it's enough of a difference on the gate of that MOSFET to trigger it to turn on, but for some reason something on this board is pulling it down before the button is even pushed. So I think well, I don't really know. I'm going to have to take this board out and have a close look at what's going on the other side. There may be some issue. There may be another couple of resistors there. There's some kind of voltage divider or something. But that's where we're up to. This board has our main input cable and then a couple of other cables coming off it for the lighting around the place. There's LEDs all over the front of this thing. So we'll unplug them first, and I'm wondering if someone may have been in here before. Ooh, hello. There's a rotary encoder here. It's been snapped off the front. That's what that bit of tape was. There's a bit of tape stuck across a hole in the front, and I thought maybe an insert for lighting had come off, but no, it's actually, there's the remains of a rotary encoder. And this looks pretty rough along the bottom here underneath this tape. I wonder what's... Ooh, okay. We have a Zener... Oh, sorry. Not a Zener. A little glass diode here. We've got a little glass diode here that's actually smashed. And this is our center button, our on-off button. There is a resistor going in there, but that doesn't seem to go. May have to peel this tape back and see what's going on under there. I think that may be a problem too. You can see the PCB's been fully chewed away there for some reason, which is quite strange because there's nothing where that sits that indicates why that would happen. It doesn't look too bad. The soldering's not the best, but everything seems to be intact. This is the main connector to the cable strip that goes up to the main board. We come along, they all look okay, those resistors look okay. There's our destroyed rotary encoder. I don't know if it's a jog wheel for volume or track select perhaps, or it could be anything. And then below that, this is what I was talking about, and it does look like it has cut into the copper. Interestingly though, there's just a flat plastic edge that comes across here, so I don't know how this could have been so destroyed. What was jammed up under here? Let's peel that back a little bit. It's almost like something like this is the front facing part of the board, so it's almost like something, maybe when this was snapped off, something was forced down in the front of it and scraped along through here, but it's clearly cut through that trace and that trace at the bottom. And be interesting to see where they go to, because if we, well, there's our broken diode. So this is a power supply. So what's going on the front board that needs its own power supply? I wonder. I don't think it's not the Bluetooth receiver. Well, there's our button of concern, and that was the broken connection there. This bottom right pin is the one that I soldered, and when I did, I had a connection through from the pin to the main connector at the end of the ribbon cable up on the board. Now, and not long after that, I lost that connection. Moving on, I'm an idiot, a complete idiot. When I was doing this button, yeah, for sure, I measured it down here on the connector, and for sure I was getting a pull down to ground when I pushed it, and I was sure I was on the right pin, but guess what? I was off by one, and it led me down the garden path. Somehow I ended up measuring the second pin in, but it's the third pin in that we need. And if we follow, we'll find out exactly where our problem is. It goes on the other side of the board through to this through hole, and then it travels up here, along here, around here, and down here, and down to this transistor. You know what's coming up next, don't you? This rotary encoder is not just a rotary encoder. It used to have a push feature. It had a switch built in. This rotary encoder knob would have been our on-off button as well. You can see it's switching this transistor here, which is going to pull this, guarantee it, put $1,000 on it, why not 10,000, and use that to pull the on-off signal to ground. And yep, what a faux pas that is, huh? But I don't know if it's used after it's turned on. It must be used after it's turned on to turn it off again as well, surely. I don't think it's used as a mode select button after the fact, but I mean, anything's possible. But it does go through to another pin on the connector. Almost got broken there. And it does also go up the side around here to another through hole there. Bet I know where that goes. Which actually, in a roundabout way, does go back up to that button. What does that measure like? If I go there to there, I've got a diode, anode to cathode at the top that way, but nothing that way, nothing that way, nothing that way. Ah, there we go. Got a, it looks like possibly a twin diode package, not a transistor as such. I'm going to plug this in and see what voltage is going on there, but I mean, who cares? It's going to work. We need to replace that rotary encoder with a button there, but I think what I'm going to do is I'll just do something like this and join those two together, and the unit should power on. At least as much as I can maybe tell, and perhaps we'll get some LEDs light up on the front. But we need to check out that broken diode up there, and I don't think it's going to be an issue, and I do think it could be a Zener, because the data sheet for that switching IC, which is a JW5116, doesn't show, it shows a standard schematic, but it doesn't have that diode in there. So I think they've thrown in a diode for a bit of extra protection. I don't think it's going to do any more than maybe 12 volts. It's got a 16 volt cap here on the output, so I think it's just 12 volts. I think it's probably just for the lighting on the front as well. So there's nothing critical really. I don't think we need that Zener at all, and it is broken. It's not actually connecting through the center. Check that. So I'm going to plug it in, jam those two together, and see what happens. Aha! So we have our blue lights on. That's a good start. So we know that that is our power button, it would seem. So let's fix up that trace down the bottom there and pop it back in the case, see if the lights come on, make sure the speakers operate, see if the Bluetooth is active. Then we'll know where we stand or whether there's another problem. Now I did check this circuit up here, and it's got 6 volts coming out of it, so whether that's going to change under load I don't know, but it's pretty low. But then I suppose it doesn't need too much for just a few LEDs. Right, we're all plugged in. Got it set up inside the carcass of the beast. We'll switch her on.
Bluetooth mode.
Oh, there we go. Bluetooth mode. Beep, beep, beep. That's good to know. Oh, we've got a little blinky blue LED on the front there, so I wonder if she's visible. If we go scan, here we go. So it shows up as, oh, right there, BSBB100. We want to, here we go, connected for audio. Maybe a signal generator. Here we go. Well, that seems to be working. Great. So, the LEDs, colourful LEDs around the front look like they're working. They can be turned off and on with that button there, I think. Turns them off, that turns them on. Right, let's see if we can find a rotary encoder. Well, here we have the only rotary encoder I can find in my stash of junk. It is out of a JVC head unit. It's off the faceplate for a JVC car radio, and it looks like the mounting pieces on the side there, the mounting pins, are going to line up with the holes in the board quite nicely. Now the main contacts are very differently spaced, but what you can do is probably just bend them out, keep the center one there and bend the others out and run jumper wires to them. and then the switch contacts at the bottom here, they stick out all kinds of angles, so again we can bend them up so that they're not on the board and run jumper wires to the holes. Now I did remove this with hot air and it feels a bit funny, so I'm hoping I didn't do too much damage. It kind of feels like it still clicks. It's just a little not as smooth as I'd like. So yeah, I don't know, I might have got that a little bit hot when I was pulling it out. But that's fine. I have another one identical if this turns to custard. So if we go across those two there, and oh, we want to go into beep, so you can hear the beep. Oh, come on. Uh-oh. Oh dear. Maybe that's not the correct pins. Maybe I've cooked it. I should have checked that before I pulled them off. There we go. Well, I took it apart and had a bit of a look. I was completely wrong about the pin configuration, and it seems that our switch is the center one, and this one up on the top right, top left, and the two outer ones, well, I suppose they kind of sit like this now, don't they? They're the three that play a role in the rotary encoder side of things. So doesn't seem to be anything worrying about that now. I can reuse that one, but looking at the old one, trying to see, it's got two connections. Just wondering if it might encode in the same way or not. Is the center one connected to anything? It doesn't seem to be. And there's no sign of where this half, because it went like this effectively, there's no sign of where that broke. That third pin may have come through. Ah, there you go. So the center one goes to one of these fingers, two of these fingers, and then the outer one just goes to the outer finger. There we go. So the center one would have been common to possibly common, and the other two would have alternated accordingly. So what does that mean? This one's our center pin and these are our left and right. That's going to make it even more fun to wire up, but that's fine. Let's run with that. Let's run with that. It'll either work or it won't. I don't think it's going to be a problem if it's wired up wrong, because these signals are being pulled high and low all over the place. So I'll put this back together and then we'll see how it lines up on the board the other way around. Okay, this is a nice long one, but I'm in lockdown, so I don't care, and you might be too, so what else are you going to do? Might as well watch the whole thing. So I pinched the other one because this is so much more tactile response. Oh, it's getting late. It's now 10 PM on the second day of recording this one because of a bit of a hold up. Yep. Okay, and the top right was our common. So because of the positions they are, I'm going to mount it upside down to what I thought it was, so that the center pin doesn't cover the hole up top, because we need to be able to access that. So I'm just going to tuck that up like that, tuck that one up, that one will come up a bit as well, and I'm going to be fairly out the way of, I mean, it's going to be sitting on solder mask, so it's going to be fairly okay. Let's see if I can poke that down the hole. Ooh, that's tight. Here we go. Not bad. I think there's a bit of extra solder on those pieces. It was making it a bit snug in the hole. But, yeah, alright, so let's hook up that, and that was our common, so they can go in the middle and those two can go on the sides, and should be good to go. What am I going to use for wire? How about some old IDE cable? Sounds like a plan. Well, there's the masterpiece in all its glory. I'm not going to solder on the anchor points on the side there, just in case this doesn't work at all and I have to remove it. There's no point in having to try and desolder those. They're quite a snug fit as it was. But yeah, let's plug it in and see if it responds. The on-off button's definitely going to work. We hit the power button there. Oh,
Bluetooth mode.
Okay, make sure that our Bluetooth pairs. Oh, sounds like it did. And we'll get our signal generator on again. Here we go. So what happens if I rotate the control? Volume. Hey, it works. What if I push it once? Okay, I thought it might be mute. Well, that's cool. Okay, well, winner winner. I think it might be a go. That's pretty cool. Alright, my app turned off. Right, let's solder this back in completely, secure it, tidy it up, and put it back together. Okay, so here we go. I've even got the knob off of the faceplate. I mean, where am I going to find a bigger knob at this time of night? Anyway, we're on battery at the moment.
Bluetooth mode.
It's interesting that it doesn't really seem to come up as quick as on mains, but that's fine. Look at the colours. It's pretty cool, huh? Now if I push this button for light, turns them off and on. Now this says auxiliary in. This says auxiliary in on the light button, and that's what I wasn't sure about, because if I put it into
auxiliary mode,
that comes up, but
Bluetooth mode.
text wording kind of cuts off at the start when it says Bluetooth. But anyway, this one's bass boost and USB. If I hold that down, ooh, it doesn't push very well. No, hold that down. The USB doesn't light up. Maybe I have to plug a USB stick in anyway. Got a white light for bass boost on and off, but anyway, there we go. And of course we've got, where are we? Some kind of audio. So yeah, there we have it. Thanks for watching. Physical damage repair is just a matter of, find it and fix it. There's no fault finding to work out what parts failed as such, but hey, at least we worked through the process to find out what wire turns this thing on. Well, if you're in lockdown, I hope you're not getting too bored, and keep safe when you go out and about, and we'll catch you next time.